Hi students, welcome to my YouTube channel, and in today's video we will learn about refraction. This video will be the basic part of refraction. In my next upcoming video we will learn some deeper about it. So what is refraction? So refraction is very important to describe some natural phenomenon like rainbow formation after rainfall, even twinkling of star in clear sky that you will find in at night is also an example of refraction. And even the camera lenses that also use the formula of refraction and reflection. So refraction is only observed when you pass light from one medium to another medium. Suppose this is the boundary between two medium, and this is the air medium and this is the water medium. And this is the normal I have just drawn on the boundary of these two medium. And suppose a light is passing from air medium to water medium. So as the velocity of light is maximum in air and vacuum medium, it will be 3 into 10 to the power 8 meter per second. But the velocity of light will decrease in water medium. So the refraction will happen in this way. The direction of light will slightly move or bends towards the normal. So this is the angle of incidence and this is the angle of refraction. And if we extend the line, this angle is called delta. As here we can see that angle of incidence is greater than angle of refraction. So we can say that delta is equal to I minus R. And if we just do the reverse, for example, if we pass light from water medium to air medium, we'll see that the direction of light changes and it slightly bends away from the normal. And this will be the angle of incidence, this will be angle of refracted rays. If we extend the line, we'll find that this is the delta, and as here the angle of refraction is greater than the angle of incidence, it will be delta is equal to R minus I. So this is the thing about refraction. And another way of refraction may also happen, that when light moves along the normal in this way. So actually there is no deviation will occur, so we'll discuss about it later. So just first focus on these two things. So the velocity of light will decrease in this case from air to water medium, we will say that water medium is optically denser than air. Now what is optical density? Actually optical density is only depends on the velocity of light. Okay, as the velocity of light is decreasing in this water medium, so this is optically denser than air medium. That is why the refraction is happening, but it not depends on the density of any medium. Suppose you are passing light from water to kerosene medium. So we know that kerosene floats on water. So the density of kerosene is less than water. But when you pass light from water to kerosene, we will see these things, because as the velocity of light will decrease in kerosene medium, so we will say that kerosene is optically denser than water. I'm just writing this over here for your convenience. So I hope you understand. So that is about optical density. But when reverse things happen, for example, you can see that light passing from water medium to air medium, and as its velocity is increasing and it is slightly bending away from the normal. In this case, we will say that air medium is optically rarer than water medium, as the velocity is increasing over here, but the velocity is decreasing over here. That is why we will say that this is water medium is optically denser than air medium, or you can say that kerosene is optically denser than water medium. So I hope you understand the thing. And now just I have told you that when light move from any medium, one medium to another medium, if it moves along the normal of the boundary, or the ray of light incident normally on the surface or the boundary between boundary separating the two medium, as here angle of incidence will be 0 and angle of refraction will be 0. That is why delta is equal to 0. There will be no deviation of light. It will simply moves linearly. So that is the thing. And here this will be 90 degree. So these three things can be happened. Okay. The very important thing is what is laws of refraction. So laws of refraction actually proposed by Snell. That is why it is called as Snell's law. So the first thing is the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. So for example, just look at this thing that I have told you the thing just now, that when light moves, light incident normally on the surface, on the boundary between two medium. So in this example, you will find that the incident ray, this thing, and this is the refracted ray and the normal. Are you seeing the normal? This is along this line. So normal at the point of incidence, this is the point of incidence, all lie in the same plane. And one thing I have to say that you will draw the normal only on the point on which the light will incident. If the light suppose incident in this point, so you cannot draw the normal here. You just have to draw the normal at this point, covering the point of incident. Now, the second law says the ratio of sine of the angle of incidence I to the sine of angle of refraction R is constant for the pair of given media. So you have to remember the thing. This is sine I by sine R. It will be constant. And this constant is actually called the refractive index. It is denoted by the sign mu. Now, one thing you must remember that intensity of refracted ray is always less than the intensity of incident ray, because some amount of light will also reflect from this boundary. That refractive index mu is equal to c by v, where c is the velocity of light in vacuum medium, while v is the velocity of light in the medium on which you have to determine the refractive index of that medium. Mu can be written as, when mu will be determined between two different medium rather than your air or vacuum medium, it can be written as, suppose 1 mu 2. So here you have to determine the refractive index of second medium 2 with respect to 1, and here it can be determined as speed of light in medium 1 by speed of light in medium 2. So always remember, on the medium on which you want to determine the refractive index of the second one, so you have to put the first one in the numerator position, while the second one at the denominator position. So I hope you understand. And now, this is actually absolute refractive index, because in this case the velocity of light has been determined with respect to vacuum or air medium. So this is actually the absolute refractive index. Okay, where you will determine the refractive index of any other medium with respect to air medium or vacuum medium. So now speed of light, so we can say this is V1 and this is V2. So earlier I have told you that absolute refractive index is equal to C by V. So for V1 it will be mu1 is equal to C by V1, where mu2 is equal to C by V2. This is the absolute refractive index of medium 1 and this is the absolute refractive index of medium 2. Now from here we can we can say that V1 is equal to C by mu1 and V2 is equal to C by mu2. So if we put the value over here, we'll get C by mu1 by C by mu2. C by mu1 into mu2 by C. So the final thing will be mu2 by mu1. So we can conclude that 1 mu2 is equal to mu2 by mu1. So this is the formula I have written over here. So you have to remember the formula while determining refractive index of any other medium. For example, suppose you were to say refractive index of glass with respect to air medium. So we all know that mu w, refractive index of water, is equal to 3 into 10 to the power 8, because you all know that the velocity of light in vacuum or air medium is 3 into 10 to the power 8 meter per second. And in glass medium, the velocity of light will be 2 into 10 to the power 8. So the final answer will be 1.5. Now, actually refractive index have no unit as it is a ratio. So this is the refractive index of glass. This is the refractive index of glass. So if you are told that what it means that refractive index of glass is equal to 1.5, it means that the velocity of light in air medium is 1.5 times greater than the velocity of light in glass medium. Now, conditions for a light ray to pass undeviated on refraction. So the first one is angle of incidence is equal to 0, and second one is mu1 is equal to mu2. That is the refractive index of both media is same. So this is a general way. If the refractive index of both media is same, so we can say that both media are equally optically denser to light, and that is why they will move without any deviation in these two media. Now, and the second thing is angle of incidence is 0. Here you can see if this light falls along the normal, there is no deviation when passing through one media to another media. So in this case you can say that this is the example or conditions for a light ray to pass undeviated on refraction. Now next move on to the second thing, relationship between wavelength in the two medium. So here you can see that is lambda dash is equal to lambda by mu. So actually what it means, for this thing I want to say that actually wavelength of light is equal to velocity by frequency. So the first one is wavelength. So what is wavelength? Actually the distance between the successive crest of wave is lambda. Actually light moves in a waveform. For example, you can see that this is the way on which the light ray will pass. Now what do we see, that light ray moves in a linear way, but actually it is actually moving in a waveform. The distance between, for example, this is the crest and this is the tuff, and now the distance between successive crest of wave is lambda. So this is the thing, this is the lambda. This is the first crest and this is the second crest, and the distance between them is lambda. And what is frequency? That is f. Frequency is the number of waves that pass by each second. For example, there is one light ray that is passing in a 1 second. It is at this position. Another light that is passing in. Are you getting the difference? That here the second light ray has less wavelength with respect to time, while the first one has greater wavelength with time. That is why the frequency of the first one is greater than the frequency of the second one. Here, as it is passing more number of waves in 1 second, while the second ray is passing less number of waves in with time. That is why it is the difference. Now, actually frequency is only depend on the source of light. In refraction, frequency does not play any role, but the velocity of light play any role. Just now I have told you. This is the short form I have written, the speed of light proportional to approximation from normal. So it means that if speed of light increases, approximation from normal will increase. It means that light ray will bend away from the normal. While if the speed of light is decreased or slows down, then the approximation from normal will decrease. It means that light ray will bend towards the normal. So this is the formula. Here frequency is constant. That frequency has no role in this refractive index. So we can say that lambda proportional to v, we can say that the light ray which has greater velocity, it will have greater lambda or greater wavelength. And now mu is equal to v by v dash. Now we know that velocity, this is the velocity, suppose this is the velocity of 1 meter, this is the velocity of second media. Now we can also say that as v proportional to lambda, we can also say that this thing. So finally we can write that lambda dash is equal to lambda by mu. So it means that so as refractive index is directly related to velocity of light, and velocity of light is directly proportional to wavelength of the light ray. So we can say that lambda dash is equal to lambda by mu. Now there is another thing I must say, that here you can see that absolute refractive index is equal to c by v. So where c is the velocity of light in air or vacuum media, where v is the velocity of light in any media. So as the velocity of light is maximum in air media, so definitely numerator will always be greater than denominator. That is why mu or absolute refractive index will always greater than 1. Now the next thing, factors affecting the refractive index of a medium. So nature of the medium. So just I have told you that what is optical density. Suppose light is passing from this medium to this medium, and this is a normal, and light is passing from this medium to this medium, and this medium, the second medium, is optically denser than the first medium. That is why the velocity of light ray in the second medium will slows down and it will slightly bend towards the normal. From this you can say that refractive index mu is dependent on the nature of the medium. I have told you that mu is equal to sin I by sin R. Now what is sin I? This is the sin I, or this is the I, angle of incidence, this is the angle of refracted ray, R. So this is the this is mu is highly dependent on this two angle. That is why mu is depends on the nature of the medium. Now the next thing, temperature. So with increase in temperature, mu will decrease. It means that now with increase in temperature, the force of attraction between the molecules between the atoms of any gas, liquid or solid, any medium will, that is why their density will decrease with rise in temperature. And as their density is decreasing, and velocity of light ray in this media will also increase, because we know that mu12 is equal to mu2 by mu1, and this is equal to v1 by v2. If v2 increase, velocity of light ray in the second media increase, so this mu12 will also decrease, because suppose previously it was 2 into 3 into 10 to the power 8 by 2 into 10 to the power 8, and now it will be, suppose now it becomes 3 into 10 to the power 8 by 2.5 into 10 to the power 8. In this case, as the velocity of light is increasing in the second media due to the increase in temperature, so if we calculate the value, it will be 1.5, and if we calculate this value, it will be 30 by 25 is equal to 5 is equal to 1.2. Here, are you getting my point? That here the value is decreasing. The value is decreased from 1.5 to 1.2. So we can say that mu get decreased or mu is reduced with increase in temperature. Now velocity, refractive index of light is also depend on the color of the light. As the wavelength of red light is very high, so it will exert more velocity in any media. Suppose in the case there is two media, and when red light pass from this medium to this medium, the red light in the second media, that is the optically dense media, so it will bend towards the normal. But if you use violet light that has very less wavelength with respect to red light, then the velocity of the violet light will be less than the velocity of red light in the second media. So it will move, it will bend more towards the normal, and thus our angle of refracted ray will be smaller than this case where we use red light. So if we calculate the refractive index of two medium, we'll get that mu is equal to velocity v1 by v2. So as v1 is suppose 3 into 10 to the power 8, and velocity of red light in this media suppose 2 into 10 to the power 8 meter per second, and in this case the velocity of light of violet light in the second medium is, suppose as it is decreased, suppose it is 1.8 into 10 to the power 8 meter per second. So if we calculate the two things, we will get that this will be 3 by 2 or 1.5, and this will be 3 by 1.8 into 10. So it will be 2 by 3, and now it will be 6 point. So you can see that refractive index in this media where you use red light is less than the refractive index of this media where you use the violet light. So from this we can conclude that as the wavelength increases from violet light to red light, or you can say that red light has greater wavelength than violet light, so it has the velocity of red light in any media is greater than velocity of violet light. That is why the angle of refraction in this case where we use the violet light is less than the angle of refraction in this case where we use red light. So we can say that with increase in wavelength from here to here, velocity of light in any media will increase, and thus the angle of refraction from here to here, you can say, will increase, and thus the refractive index, as here you can see the refractive index is 1.5 for this case and 6.6 for this case, refractive index will decrease. So that is the reason why we say value of refractive index depends on the color of the light we use.
So if you have any doubts, go straight to the comment section, ask me, and if you want any short notes from this chapter, then mail me. I have given my mail address in the description box. Check it there, and I will provide the PDFs of those short notes to you. Finally, thank you for watching.